Hello, family. It's Miss 4 here to teach you how to solve exponential equations. We're going to focus on exponential equations that have a base of e, but to begin with, we're going to look at a number base. We're going to look at a basic equation to get an idea about how this works. So let's start with a really basic equation. Let's do x plus 2 equals 8. The purpose of this equation is we want to know what x has to be in order for this side that's showing to equal 8. So some of you guys can just do that in your head. What does x need to be in order for it to equal 8? If you add 2 to it, it equals 8. Well, if we're going to solve this equation, what we're trying to do is get this x all by itself. We're trying to isolate the x. So if we want to eliminate or get rid of this plus 2, we do the inverse of what we see. So remember, inverse means opposite. So if we want to get rid of a plus 2, so get rid of in quotation marks, we are going to do its inverse, which is minus 2. When I do that, these two things go away, meaning they are no longer on the left-hand side. Plus 2 and negative 2 cancel out, and all I have left is x. Because this is an equation, it needs to remain balanced, meaning if I take 2 from the left, I also need to take 2 from the right. So 8 minus 2 will give me 6. So x has to be 6 in order to make this thing equal 8. So 6 plus 2 is 8. Now let's change it up a little bit. Instead of x plus 2, let's say 2 to the x. And that's still going to equal 8. So now you have your x up in the exponent position, and we haven't learned ever how to solve an equation when the x is in the exponent position, because we have to know how to get it out. We have to know what is the inverse of a base 2 exponent. Well, it turns out that its inverse is log base 2. So over here, we have our operation and our inverse. So the opposite of add is subtract. Opposite of multiply is divide. Opposite of x squared is root x. Opposite of 10 to the x is log base 10. Opposite of 2 to the x is log base 2. Opposite of e to the x is the natural log x. So one thing to notice here is that the base number on the log and the exponent are the same. So 10 to the x, the inverse is log base 10. 2 to the x, the inverse is log base 2. E to the x is natural log, but hopefully you're remembering this is the same thing as log base e to the x. So over here, if I want to get rid of this 2 as a base, what I say is log base 2 of 2 to the x equals log base 2 of 8. These now go away. And what you're left with on the left-hand side is x. And on the right-hand side, if you plug it into Desmos, if you plug it into your calculator, so I'm going to use change of base form, and I'm going to do log 8 divided by log 2. My answer is 3. X is 3. because 2 to the third is 8. Similarly, let's say we have e to the x equals lucky number 13. Well, if I want to get rid of this e as my base, I take the natural log of e to the x and the natural log of 13. These go away now. On the left, I have x, and on the right, I have natural log 13, and we're just going to leave it like that. Natural log 13 is the exact value. The approximate value would be 2.5649, but we just want to leave it as natural log 13. So this is the very basics, and the takeaway is that the inverse of an exponent or an exponential is a logarithm. So on this page, if I flip back, I will remind you that all of the problems that we are doing on this page have base e. I should probably also remind you that e is just a special number. So the number e is one of the most important numbers in mathematics. The first few digits, that's like a majillion digits, are listed here for you. This is called Euler's number. So we just call them e though, because e is easier. And we call pi, pi. And e, e, even though it's really Euler's number, which is spelled like Euler. So remember, e is just a special number, and it models natural growth or decay. So e models natural growth or decay. So that's like plants growing and plants dying. Bacteria, the COVID virus, growing in your body and then decaying, and you get better. The reason that we have the natural log is because e models natural growth. So that's why the inverse of e is natural log. Okay, first problem. I need to get rid of this e so that I can pull this 5x out of the exponent position. So the first thing that needs to go is this base e. So I take the natural log of e to the 5x equals the natural log of 7. These on the left-hand side go away, and I get 5x equals natural log 7. Then my last step, I have 5 times x now. I'm going to divide the x off, and I get x equals natural log 7 over 5. Now sometimes they separate the natural log from the fraction, and that is allowed. So sometimes they take the natural log and they pull it out of the top of the fraction and put it just right next to the fraction. So then what do we put in the top as a placeholder? Well, we can't put 0 because 0 divided by 5 is 0. So the placeholder would have to be 1. So if you get a solution like this, I want you to write the answer both ways. I want you to write natural log 7 over 5, and then 1/5 log 7, natural log 7. Okay, next guy, same thing. We have an e here, so we need to try to get rid of that e by taking the natural log, because that's the inverse of e as a base, of both sides. These go away. On the left-hand side, I'm left with 2x. On the right-hand side, I'm left with the natural log of 9. The last step, just like in the previous problem, is to divide by 2. So x equals natural log 9 over 2, or, see if you know, 1/2 natural log 9. So you just pull that natural log out of the top and use 1 as your placeholder. Okay, number 3. We have one slight addition, and that addition is that there's a 2 on the front now. So we don't have just E, we now have this 2 hanging out here. And that is a problemo. So instead of our first step being to get rid of the E, we actually have to get rid of this 2. To do that, you're going to divide both sides by 2. Before you can take the natural log, the only thing that can be on the left-hand side is E. Those go away, and we're left with e to the x equals 5. Now we're in the position to take the natural log of both sides. So natural log e to the x, because these two need to be right next to each other, natural log and e. So we could not have done it up here. We cannot do natural log 2 e to the x. It has to be natural log e equals natural log 5. These go away, and x is just the natural log of 5. For number 3, it's exactly the same, well, almost exactly the same as the other ones. So I'm going to do 4 with you, and then I want you to try 5 and 6 on your own. Like, I want you to literally pause the video and try 5 and 6 on your own. So step number 1 on number 4, we need to get rid of this 3 first, because we can't take the natural log until it's just e. So I'm going to divide both sides by 3. That gives me e to the 5x equals 4. From here, I can take the natural log of both sides. Natural log e to the 5x, natural log 4. Natural log and base e go away. 5x equals natural log 4. Now we divide both sides by 5, and x equals the natural log of 4 over 5, which is the same thing as 1 over 5 times the natural log of 4. So I'm going to work out the next 2. I'm not really going to say anything. I'm just going to work them out, and you should solve them as well. When I'm done, I'll say pause. So if you're not done, you can finish them, and then you can check your answer. So we're solving 5 and 6 on our own. Really try it on your own, guys. Don't just depend on me. Okay, if you're not done, pause so that you have enough time to finish, and then check your answers. Okay, this is my answer for those two. Seven, 5, and 9. That's interesting. 7, 5, and 9. This should be an 8. Just have an added element. So number 7, sorry, my face is in a weird spot, is like a girlfriend equation. But the girlfriend equation is like surrounding the exponential. So we solve this, pretend like this e to the x is what we're isolating. The first thing that we would need to do is get rid of this friend, -7. To do that, we add 7 to both sides. That leaves us with 4e to the 5x equals 20. Now we got to get rid of this girlfriend. So to get rid of the girlfriend, we divide by 4. That leaves us with e to the 5x on the left and 5 on the right. And now this is solving an exponential equation where we take the natural log of both sides. So the girlfriend equation, you have an exponential in the girlfriend equation. These go away, and we're left with 5x equals natural log 5. And hopefully now we know what to do from here. We divide both sides by 5, and we get x is equal to x is equal to the natural log of 5 over 5. And I should have mentioned this sooner, but make sure that your number, that last number you're dividing by, make sure that your fraction line is covering that whole natural log. So you're dividing natural log 5 by 5, or you change it to 1/5 natural log 5. Now number 9 is almost exactly the same. So see if you can follow my steps for number 7 to do number 9. I'm just going to work on it quietly. When I'm done, I will tell you that I'm done so that you can pause and finish it before you see the answer. Okay, I'm done. So for number 9, I changed 16 divided by 5 to a decimal because it ends up being a nice decimal. So 3.2. Final answer is natural log 3.2 divided by 4, or 1/4 natural log 3.2. Number 8 is the only one that does not end up like a fraction. So we do not have a girlfriend. We have e to the x plus 1. All we have is this friend plus 5. So the first thing we do is subtract 5. And we get e to the x plus 1 equals 15. And at this point, we can take the natural log of both sides. What's different about this one, when we get rid of the natural log and the base e, is we have x plus 1 instead of something like 5x or 4x or 10x. To get rid of that plus 1, we just subtract 1 from both sides, and your final answer on this guy ends up being the natural log of 15. Sorry, I ran out of space on my flash drive. So it stopped my recording right as I was saying the final answer on number 8 is the natural log of 15 minus 1. So like I was saying before, it is the only one that does not have a fraction as its final answer. One thing that I've waited to mention until now is that you can get an idea about whether or not your answer is right by using Desmos. Now, for these exponential ones, it's not as helpful because all of these are going to be really long decimals. They're irrational numbers. So if I go to Desmos, I have mine pulled up in the background. I'm on the graphing calculator one. So if you're going to Desmos.com, the first thing that you see is this page, Let's Learn Together. You're going to select Math Tools, go to the graphing calculator, and in here I can type in the equation E, shift 6, parenthesis x plus 1 equals, oh, sorry, I forgot the plus 5, equals 20. Now, this vertical line here is telling me, sorry, I was just trying to zoom out a little bit. This vertical line here, this red vertical line, is what the solution is. It's showing up as a vertical line because we're in the graphing portion of Desmos. So if I look at this, it's not awesome, but it looks like it's almost 2. Well, the reason why it's not turning out as a great answer is because if I plug in what we got, natural log 15 minus 1, you can see that the right answer is this big old exploding number. And if I go back now to my graph and look at that, I can see that that does look around 1.7. So for these solving exponential equations ones, not so useful because all of these are going to be decimal answers. But on the next page where it's asking us to solve logarithmic equations, this is much more helpful. So I'm actually going to plug in number 2 first. I'm going to plug in number 2 to Desmos. I'm going to try to just move this slightly out of the way. So I am going to type in log, just L-O-G, parenthesis, 3. Now it says P, but remember, we always put in X. Even if it's like Y, we still just put in X. So log 3x plus 6, n parenthesis, equals log 21. And now this time I'm getting a really nice answer. This is telling me that the solution to number 2 on the back side of our note sheet is 5. So number 2 is x is 5. Okay, well the one below it has a log base 17. How annoying. Log base 17. Well, we can solve these ones with Desmos as well. If you guys push or click on the colored dot that's next to the function you're graphing, it goes away. It mutes it. So if I hit this button, it like puts the line on and takes the line off. So I'm going to mute that one below, and I'm going to try to graph number 4. Now I have to pull up my keyboard that's at the bottom of Desmos. So, right down here in the bottom left, you'll see like this little icon, bottom left of the screen for the keyboard. So you hit that and it's going to pull up this big keyboard. Sorry, I need to make this a little bit smaller. There we go. And what I'm going to want to press here is this functions over on the right-hand side of the keyboard. Then I'm going to scroll down until I find this log A button. So I'm in the wrong spot over here. I need to click into my new line, functions, log A. And then I'm going to type in 17 in the parentheses 2x, even though it says n, equals, and then I'm just going to copy and paste this log 17 to the next side. Log 17 of negative 3x plus 4. This time it's looking like I have a line at what seems to be a fraction. So I'm not sure if we zoom in anymore, if that's going to help us. I'll try. Yeah, so the best I can get on this one is like, I don't know, 0.8, 0.8. So I think on my worksheet I would write x is 0.8. On your quiz for this, it actually gives you multiple choice answers, so you'll be able to have a better idea of what this may be. Let me just make sure that I type this in okay, because I'm not used to the answer being like that. Log base 17 of 2x equals log base 17 of negative 3x plus 4. Okay, let's try the one below it. So let's try the natural log base 12 one. So I can just copy and paste this from above again and just change that 17 to a 12. So log base 12 of negative 4x plus 2 equals log base 12 of negative 5x. Okay, this one works out nicely. So number 6 is negative 2. I see this big dark line at negative 2. So number 6, x equals negative 2. Okay, let's have you guys try number 5 without me. So I'm going to move my Desmos over, and I want you guys to try number 5, just so that you can verify that you can get the right answer. I'm just going to be plugging mine into Desmos, while you are hopefully plugging yours into Desmos. Sorry if I'm slower than you. Okay, I'm getting 1. X is 1 on 5. On number 3, remember this is one that we can just type in. So for number 3 in Desmos, I can just type in ln parenthesis 2x plus 7 equals ln parenthesis 10 minus x. So this one is also 1. So number 3 is x is 1. So I saved the number 1 for last. We have a 7, 8, 9, 10, but we're going to skip those. And the last thing that we are going to look at is number 1. So I'm just going to use this log base 17 that I already have written down. If you need to start a new one, go ahead. But I'm plugging in log base 17 of negative 4x plus 9 equals log base 17 of negative 5x. And then I'm going to go over to my graph and look for the line. So I don't immediately see it in Desmos. So I'm going to use this little negative button above the house, and I'm going to start zooming out to see if I can find the solution for this guy. It looks like he's right here. Is that true? Oh, it's a minus 9. I typed in the wrong thing. Negative 4x minus 9 equals negative 5x. So that one went away, and I'm just going to keep zooming out. And by the time I've zoomed out this far, like I've zoomed out 100 and see no solution, that means that what I should write here is no solution. If a vertical line does not show up, then that means that your equation does not have a solution. So for solving exponential equations, your first part of your quiz matches this. You're going to write all of your answers in terms of a natural log. So on quiz 5.6, your answers should look like these answers. But for the back side, you're just going to plug these into Desmos. And on this one, it actually gives you multiple choice options. And remember, if you don't see a line, it's going to be no solution. But otherwise, you should see one of the answer options. So, sorry this video was a little bit longer. Hopefully if it's too slow for you, you can speed up the pace on YouTube. I think all of you guys know that, but if you didn't, you can change the speed that you hear me talking at. There's a button on there and you can make me talk twice as fast, or you can fast forward over things that you don't need. So hopefully it wasn't as long as the full 30 minutes or whatever. I try to keep them shorter than that, but this one was a little bit longer. Okay, that's it. Give your quiz a try.